Ever wonder how the smartphone in your hand or the car in your driveway gets made? We're talking millions of complex products, all built with what looks like impossible speed and precision. Well, it's not magic, not at all. It's a science, a hidden science, really, the science of the assembly line. And today, we're going to pull back that curtain and uncover the secrets to getting that perfect, efficient production rhythm.
You know the feeling, right? You're at the grocery store, maybe grabbing a coffee, and the entire line just stops, grinds to a halt, all because one person is fumbling around, holding everything up. It is so frustrating, because you're ready, everyone else is ready, but you're all just stuck there, waiting.
Okay, now take that tiny bit of frustration and just imagine scaling it way, way up. In a factory, that one slow point isn't just annoying a few people, it's holding up the entire production process. That delay has a name. It's called a bottleneck. And it creates wasted time, wasted resources, and in the high-stakes world of manufacturing, that can literally cost millions of dollars.
So, to figure out how to fix this expensive problem, we first have to understand the very heartbeat of the factory floor. Let's talk about the rhythm of production. You know, at its core, an assembly line is a pretty brilliant and simple idea. It's just a process where a product moves along, maybe on a conveyor belt, from one workstation to the next, and at each station a specific job gets done, building the final product one step at a time. Think of it like a relay race, where each person in line adds another piece to the puzzle before passing it on.
But what happens when one of those runners in the relay race is, well, just way slower than everybody else? This brings us to the central problem we're talking about today, the incredible cost of just waiting.
All right, take a look at this. It's a simple, unbalanced line. We've got 3 stations. Station 1, it takes 6 minutes. Station 2 takes 7 minutes. And look at Station 3, it's super fast, only 2 minutes. So here's the question. What do you think the true speed of this entire line is?
Now, before you answer, let's nail down a really important term: workstation cycle time. This is basically the rhythm of the line, the time between finished products rolling off the end. And here's the key, the part that might surprise you. It's not the average time of all the tasks. The cycle time for the entire system is set by the single slowest task.
That's right, 7 minutes. The cycle time for our little line here is a full 7 minutes. Even though Station 3 is a speed demon and can get its job done in just 2 minutes, it doesn't matter. It has to sit there and wait for the product to finally arrive from our bottleneck, Station 2. The whole line can only move as fast as its slowest part.
This slide just lays it all out so perfectly. Look at the left, our unbalanced line. The cycle time is stuck at 7 minutes. That means Station 1 is just sitting idle for 1 minute every cycle. And Station 3? It's idle for a whopping 5 minutes every single time. That's paid time, just completely wasted. But now look at the balanced line on the right. Every single station takes exactly 5 minutes. The cycle time is a quick 5 minutes, and there is 0 idle time. That's a 2-minute improvement on every single unit that comes off the line. That right there is efficiency.
So the big question is, how do we get from that clunky, inefficient line to the smooth, perfectly oiled machine on the right? Well, it takes a really deliberate strategy. Welcome to the balancing act.
So, assembly line balancing. That's the official name for solving this giant puzzle. The goal is to strategically assign every single little task to a workstation so that the total time spent at each station is as close to equal as you can possibly get it. The objective is simple: hunt down that expensive idle time and get rid of it.
And you know, achieving this perfect balance isn't just guesswork. It's a really methodical, step-by-step process. As you can see here, engineers first have to map out all the relationships between tasks, like what has to happen before something else can happen. Then they figure out their target speed and how many workstations they'll need. And that's all before they even start assigning the tasks. It's a whole system for designing the most efficient flow possible.
Okay, so once you know how many stations you need, how in the world do you decide what task goes where? This is where the real strategy kicks in. Let's look at the rules for creating that smooth flow.
So how do you actually decide? It's kind of like filling a jar with big rocks and small pebbles. You got to put the big rocks in first, right? Well, managers use these smart rules of thumb, or heuristics, to do just that. For example, one really common rule is to assign the task that takes the longest first. Another one is to prioritize tasks that have a ton of other tasks depending on them. By tackling these big rocks right away, they make sure all the smaller, easier tasks can fit in around them. And it's really important to know that these are called heuristic rules, because they are essentially practical shortcuts.
I mean, with thousands of different tasks, trying to find the one single, absolutely perfect solution could take a computer forever. These rules help managers find a fantastic, super efficient solution really, really quickly. It's all about being effective in the real world.
And this quote, it just sums up the whole mission beautifully. It all comes back to this one core objective: assigning every single task in just the right way to minimize that dead, unproductive, costly idle time across the entire system. Every decision is driven by that single goal.
So here's the bottom line, the crucial takeaway. The secret to a killer assembly line isn't just about making people or robots work faster, it's about making them work smarter by getting rid of all the time they spend waiting around. The goal is to turn every second of costly idle time into a second of productive, value-creating work.
So now that you know the science of balancing, I guarantee you're going to start seeing it everywhere. Think about your morning routine, or a team project at work, or even just making dinner. Where are the bottlenecks? Where's the idle time? And, more importantly, how could you rebalance the tasks to make it all flow just a little bit smoother? That's the power of thinking like an assembly line designer.